Alright, what we're going to look at next is equations that are what we like to call quadratic in form. And the reason they're quadratic in form is because this is an example of a quadratic right here. So ax squared plus bx plus c is equal to 0. And the reason it's quadratic in form, two reasons. One, if you notice in a quadratic we have three terms. Okay, and then also in a quadratic, the degree of each term decreases by the same amount every single time. So this has a degree of 2, this has a degree of 1, this has a degree of 0, so we're decreasing by 1 every single time. Well, if you look at our example of x to the fourth minus 8x squared minus 9, this has three terms, and that each one is actually decreasing by 2 each time. Now, what the book will do is they actually use substitution. If you want to refer to the book and use substitution, I'm fine with that, as long as you make sure that you plug it back in at the end and solve for your original variable x as opposed to your substituted variable. That's fine with me, but what I'm actually going to do is I'm just going to teach you how to do something like this. Now, if you notice, when you factor something that's quadratic, and that's what we're always going to try to do at the beginning is try to factor. When you factor something that's quadratic, the first term in each of your binomials actually models this one right here. Okay, it's not x squared and x squared, it's x. And the reason is because, when I multiply x times x, it gives me x squared. But then this times this and this times this will both be linear. And for us to be able to add our two like terms together, they have to both be linear to be able to add them together. I couldn't have like x squared for one and x for the other because they wouldn't be like terms. And then, so how that applies to this is I need two things that will multiply to give me this that will add to give me this. Well, two things that will add to give me this, they have to be identical. So what happens is both of these are going to be x squared. I couldn't put x to the third and x here, because if you multiply this times this, you'd get a cubic term. This times this would be linear. I couldn't add them together to get that. So both of my first terms in my binomial, they should do a couple things, multiply to give me this, but also add to give me this. So here's a little hint. Whenever you're factoring something that's quadratic in form, whatever the middle term is, that's what each of the factors of your binomial should start with. And then what we're doing, same thing in terms of factoring. Two numbers that will multiply to give me negative 9, that will add to give me a negative 8. So we're going to say it's a negative 9 and a positive 1. So what I need to do now is see if I can't factor any of those. One of these is actually factorable, so you get x plus 3, x minus 3. And of course, there is no sum of squares, even though both those are perfect squares, it's unfactorable. But now what I'm going to do is set each of my factors equal to 0 and solve. Well, this one will give me negative 3, this will give me a positive 3, and on this one, even though it's not factorable, I can still set it equal to 0 and solve. And when I take the square root of both sides, I'll actually get the solution to be plus or minus I. Now, again, remember from the first couple examples in this section that, as you can see, our degree is 4, so we should find 4 solutions. So there's one here, there's one here, and this actually makes up 2 solutions, positive I and negative I. So that gives me a total of 4, which matches the degree of my polynomial. Now, not all of these are going to be factorable, or maybe you're not comfortable factoring it. And since it's quadratic in form, we can actually use the quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now, normally we set this equal to x, but in a problem like this, just because we had this and this, we would actually have to put x squared. Okay, now based on your problem, not all of them are quadratic in form where this is a 4 and this is a 2. So you'll have to basically look at each quadratic independently, quadratic in form, and look and see what would go there. But for a problem like this, you would actually get x is equal to plus or minus the square root of negative b plus or minus the square root of b squared minus 4a times c all over 2 times a. So again, we have to get 4 solutions. This would only give us 2, but when we take the square